Good evening. Welcome to SVN3E, Environmental Science. There we go. All right. Good evening. Welcome to SVN3E, Environmental Science. And tonight, you can see, hopefully you can see the screen there. You can see that we're going to continue tonight with Unit 2. And I'm not sure we can see Unit 2, so let's go over to Unit 2 and just see if we can get that a little bit bigger on the screen here. There it is. Unit 2, Environmental Effects on Humans. We're actually going to start this unit off by looking at a little bit more of human activity and the effect on ecosystems. However, we're going to start tonight by knowing that this human activity and what it does to the ecosystem in turn affects humans when we affect the ecosystem. If we have a positive effect, that can have a positive effect on us. And if we have a negative effect on the ecosystem, it can have a negative effect on us. So Unit 2 begins with Lesson 6, which we're going to go down to right now. And we'll see there, we've got the Lesson 6. Just move that up a bit for us so we can see good. Lesson 6 learning goals are going to be students will be able to describe the effects of oil spills, acid precipitation on ecosystems, and then in turn, as I said earlier, on us, and describe the likelihood and signs of ecosystem recovery in each case. So ecosystem recovery is the most important takeaway because when we affect an ecosystem negatively, we want to make sure that we turn around and fix that damage and even perhaps improve the situation. I was hiking one time in Thailand many years ago, and the guide of the hike said that whatever ecosystem you go to, whatever environment you go to, when you leave, it should be cleaner, it should be better, it should be healthier than when you arrived. And if we all had that type of thinking, then you can imagine the world would be in a much, much better condition than it is right now. You'll see in the textbook, I'm just going to go down a tiny bit so we can see the page we're on there. On our second page of Unit 2 and Lesson 6, you'll see that there is no textbook. Not textbook. There is no information from the booklet for this lesson. So the Lesson 6 key questions are there. Remember, you want to look for the key symbol. The questions are in the textbook, and it tells you what pages to go to. And then it tells you what questions to do. Remember, we have check your understanding questions, and those are listed, and then it'll have the review questions. If you're unsure about how much to do for a question, I'm putting in the booklet next to each question is how many marks it's worth. So you can go back here and have a look before you start the key questions, so you'll be able to see how much each question is worth. Okay, so we're going to go over to the textbook because that's where the information that we need is going to be found for tonight. All right, so we're going to go to the textbook that we've been using, and we're over on Lesson 2.3 in the textbook. And you can see that now on the screen. And Lesson 2.3 is called How Human Activities Affects Ecosystems. And so we're going to look at some of these activities. Now, remember, we're going to turn around here now and we're going to begin by the end of this lesson and well into the next few lessons, looking really at how that comes back and affects us. So we'll start by looking at oil spills. We've talked a little bit about this already, actually. We've talked a little bit about oil spills, and we know that they can have a disastrous effect on ecosystems. We know anything that affects the balance of the ecosystem can really cause a lot of harm. We know that an ecosystem in balance can last a long time. We remember the story of David Latimer, who created a terrarium 60 years ago. 60 years ago, he created his terrarium and he put it inside a big kind of glass jar, and he put in the plants, animals, air, soil, water that it needed to survive. Uh, that was in I believe 60. And then 1974, he added a little bit of water. He must have felt like it was not quite in balance quite yet. And then that's it. He hasn't done anything to it since, and it continues to survive. The only thing added from outside is the sun, which is how all our ecosystems work on the planet Earth. We all have sun as the source of energy. And then remember, we have the producers, those are plants. Sometimes different bacteria can produce their own food. We call those the producers, and they absorb the sun's energy through the process of photosynthesis. They take in the sun's energy, carbon dioxide, and water, and they produce carbohydrates, which is a form of energy, food for animals, humans, and give off oxygen for us to breathe. And then the plants are eaten and by animals. Those are known as consumers. An animal that eats plants is known as a primary consumer. It's the first level. An animal that eats other animals is known as a secondary consumer. And if you have an animal that's eating other animals that's eating the plants, those are known as tertiary consumers. And if you recall last night, we even had quaternary consumers. Okay, so that's how we create the food chains of passing along the energy from the sun. It enters the ecosystem through plants, producers, and then primary, secondary, tertiary consumers eat each other, eat the animals that eat the plants, then eat those animals, then eat those animals, and you get to the top of the food chain. And those are usually animals such as wolves, humans are at the top of the food chain. It could be a bear, depending on what it's eating. It could be an eagle. Okay, there's all those top of the food chain. Anything that's dead or dying matter, remember, it gets recycled back into the environment, into the ecosystem through decomposers. And those are bacteria and fungi. Fungi can be mushrooms. This time of year, there's lots and lots of mushrooms out, and they are all different shapes, sizes, colors, and they are decomposing a lot of dead matter, including plants that are dying at this time of year, leaves, lots of leaves are being decomposed, and that energy then gets turned back into the soil and back into the ecosystem. And that cycle is a very, very important cycle of how we get energy into and through the ecosystem. We know that by just affecting one of those levels, if you affect the plant life, then the animals that survive on the plants get affected. And that can be if you have too few or too many, right? We recall that the nitrogen cycle, one of the very important cycles we talked about, if it gets disturbed, then it can have, also, as well as too little nitrogen, it can also have too much, which causes an algae bloom, and that is an overgrowth of plants. And then when that happens, they cover the sunlight for plants that are underneath them growing, perhaps in the water, and that can cause just as much damage as too little nitrogen. We know that the water that organisms live in, if it's an aquatic ecosystem, that means an ecosystem based in a lake or a pond or a river, that the plants and animals that live in that environment need dissolved oxygen. And we know the limits on the dissolved oxygen are such a range that there has to be a certain amount. It can't be too little and it can't be too much. Either end of that range then becomes toxic to the organisms living in that environment. And we also know that pH plays a big role, and we're going to talk about that again tonight. We're going to talk again about acid rain and its effect and how we create it and what it does to an ecosystem. Okay, so back to oil. So, oil spills we usually hear about are oil tankers, big ships carrying oil from where it's left the ground to where it's going to be used. The largest oil spill ever in the water was from the U.S. tanker, the Exxon Valdez. That happened in 1989 up in Alaska, and it spilled 41 million liters of oil. To put that into perspective, they have a nice chart there in Table 2.2 on page 44 of the textbook. And that chart is showing you how much oil almost 41 million liters is. So they said if you're talking about a school gym, it would be about 9 school gyms. That's how much oil that would fill. If you're talking about an average house, it would be about 142 average houses were filled with oil. Classrooms, 568 classrooms. And if you're just talking about the living room in a house, 1,022, according to their calculations of what an average living room size is. So you can understand that the amount of oil spill was immense. And it had a horrendous effect on plant and animal life in the area in Prince William Sound in Alaska. It polluted 2,000 kilometers of the coastline. It killed millions of birds, fish, animals living in that area. Millions. They still show some commercials showing how they tried to clean up that oil spill and tried to save animals, and how they still do. And so a lot of people know that it was very, very bad. Oils can also be spilled on land. That's happened as well. There's a couple of problems with oil spilling on land. We'll talk about the what it does to soil in a minute, but what it can do is it can enter the water on land by flowing into lakes, rivers, and wetlands, perhaps ponds, and it doesn't always enter accidentally. Sometimes they clean out the tankers, ship tanks, and they do that on land, and they remove the oil residue, and that's called bilge washing, where they take and clean the oil tankers tanks, and that can go into the environment if that's being done in an area where they're not keeping strict control of how much oil is entering the ground. And we know that that can be surface water, that oil can run on the surface. And we also know that it can go into the groundwater and cause all sorts of issues. When we say oil, we're talking about crude oil, petroleum products, and so we're talking about a range of products that can be made from that. How quickly the oil can spread, because that's really the problem, is if the oil spreads, then you get it over a larger surface, and that's really the issue with an oil spill. So it depends on how cold or warm the water is, the tides in the area, currents in the ocean, and the weather. If you have high winds, of course, you're going to get spread a lot quicker if it's a calm day. Relative density is the density of the solid or liquid in the water compared to the density of the water. Oil is lighter than water, so it will float on top of it and spread out horizontally until it forms a thin layer that's called an oil slick. Quite a few people are probably aware of an oil slick. However, there's also other oil that can get heavier, or it is heavier, and then it sinks, and that goes to the bottom of the lake or the ocean, and then they wash up on shore, and that can happen a long time after the spill. So you think you're kind of starting to clean up, and then these tar balls start washing ashore. Oil spilled at sea will break up and scatter into the marine environment over time, and that's known as weathering. The poor ocean has quite a time of it these days. There's all sorts of things that people will dump into the ocean thinking, oh, well, it's a big ocean, it won't affect it. And it's true, the ocean does a good job of trying to clean up all the products being put into it. You'll see there on page 45, it shows some of the ways that weathering or breaking up and scattering the oil it happens. Some of the actual products will evaporate. They're light enough that they will actually go into the air. Some of them will emulsify. Emulsification. Soap, when you use hand soap or any liquid soap, if you're washing dishes, emulsifies the oil that on the plate or whatever you're washing on the glass, and that means it allows the water to mix with the oil. So that will happen. Waves will mix the droplets of water and oil together, and then that causes it to spread out. Dissolution is when it just starts, the oil starts to break down in the water around the slick, and so it starts to enter the water. Sedimentation is when the oil travels to the bottom of the ocean and settles there. You could have biodegradation. That's actually when bacteria, fungi, and yeast actually feed on the hydrocarbons and start to break it down. And there's actually some technology that they're trying to use that hopefully can help that be a natural process. So when you have a situation like this, you have microorganisms that you can put into the water that will help the oil break down quicker. You have dispersion. That's when the waves break a slick into oil droplets, and the little droplets are spread out through the waves. And you have oxidation. That's when oil contacts water and combines with oxygen. And if you have partial oxidation, that's when you get these tar balls. So it takes a long time, though. When they say weathering occurs over time, they mean a long time. It takes a long time for the oil to be broken down properly. The effect of oil spills on the animals and plants lasts a very long time and can be very negative at every level in the ecosystem. Marine plants that live in the ocean, kelp, seagrasses, plants like that, if they get covered with oil, they die. They are not able to undergo photosynthesis because they're covered with oil, and it hides their leaves that need the oil in order to be able to break down undergo photosynthesis. And so if you have plants that get covered in oil, they will die. Once the plants die, though, all the other organisms that live dependent on the plants for food and shelter also die. So if you have organisms that, live in the plants, that's their habitat, that's where they live, that's what they eat the plants, etc., then everything dependent on the plants also die, especially the more sensitive organisms. However, you also have mammals, birds, and fish that get covered by the oil. And once you get covered by the oil, a lot of things happen. If you're a mammal, like an otter, let's say, a seal, and it gets oil on its fur, won't be able to keep warm like it usually does. The job of the fur is to keep the animal warm because they live in a cold environment. And so that will get rid of their ability to stay warm and they will just freeze to death in the water. They also can be smothered by the oil depending if they're living in the water and they get covered in the oil. They can also be smothered and unable to breathe, and then they also become poisoned and die. If you look at the next page, page 46 of the textbook, it shows some examples of animals that have been affected by oil spills. And you'll see in figure 2.14 at the top of page 46, you have a sea lion and its fur's all covered in oil. And on the right is a bird that's unable to fly because it's all covered in oil. Also, if you have fish that are covered in oil, contaminated, then the other animals, consumers, like birds and seals, will not be able to eat the fish and they will starve to death as well. And sometimes oil can smother a bird's eggs. It prevents its fish eggs from hatching. And so the breeding is interrupted from the oil spill, and that can also destroy an ecosystem. So, whether or not you're going to rely on the weathering to get rid of the oil or you're going to try to clean it up, it's going to take a long time for that ecosystem to recover. It really depends on how many organisms have been affected, and it can depend on how sensitive the environment is. If you have a shoreline that's got lots of waves and it's rocky, let's say, it could take only weeks maybe of constant waves and movement of the water and etc. But if you're somewhere where it's a lot calmer, maybe more like a sandy beach area, it could take a very long time to clean up that mess. And it can take a place like a marsh or an area where it's in the sediment in a more sandy environment. It can take years or decades to recover. So oil spills do affect ecosystems very severely. And check your understanding questions on page 46. Question number 1 asks, describe the effects of an oil spill on A, plants, B, mammals, and C, birds. That's page 46, and that's your first key question there. Check your understanding question. Question 1A, B, and C, they're all worth 1 mark. So you need to just give an effect for each one. An effect of an oil spill on plants, an effect of an oil spill on mammals, and an effect of an oil spill on birds. Okay, we also have another major effect of humans on ecosystems, and that's acid rain. If you recall, acid rain is could be precipitation, can be acid rain, it could be snow, it could be sleet. that's all different types of precipitation. And remember that acid rain is formed when sulfur dioxide and nitrous oxide are released into the air from burning fossil fuels, and then the sulfur dioxide, nitrous oxides combine with water and oxygen in the clouds and form acid rain or acid precipitation. This then falls on lakes, rivers, lands, and it increases the acidity of the water and the soil. And that process is called acidification. If you look at page 47, you'll see there in figure 2.15 the effect on the trees from acid precipitation. So you'll see there that they have very few branches, very few of the needles. They've been stripped right down and are dying from acid rain. There's two different types of acidification. Episodic acidification is a short, intense period of acid precipitation. So you'd have heavy rain, very acidic, coming down, and that would be an episodic acidification. Chronic acidification is an aquatic or terrestrial ecosystem that cannot neutralize the acid precipitation. There's so much of it that they can't even neutralize. It won't go back to normal. And why is that? Well, first of all, acid precipitation changes soil. You can't have acid rain falling on soil without having a major effect. There's nutrients in soil. Remember, we talked about how the topsoil is rich with nutrients, and we know that that has to be very balanced. Remember our range of 5.6 or higher is what we want for our acidity in soil. We don't want it to go below 5.6. Remember, acids are less than 7 on the pH scale, and we can handle, plants and organisms can handle up to about 5.6. If you go lower than that, then you're going to start to develop a lot of problems. So the amount of nutrients like calcium and magnesium in the soil, they get neutralized. In other words, the amounts get lowered. We also have trees that get their nutrients from calcium, magnesium in the soil, perhaps. And then once this happens, it does not travel into the trees like usual. And so it's going to miss those nutrients, and that's really going to affect your trees in a region. Another thing acid rain does is it adds hydrogen ions to the soil. Remember, acids come from hydrogen ions. That's what makes something acidic. It has hydrogen ions. They displace the nutrients like calcium, magnesium through a process called leaching. We've talked about leaching before. Leaching is where the good stuff in your soil comes out of the soil. And this happens with acid rain. And it removes substances that have dissolved in the soil. So basic nutrients get washed deeper. And remember, we want our nutrients to be closer to the topsoil, the A horizon. Remember, we talked about the A horizon. And if the nutrients move out of that, we get to a point where the roots of the plants and trees can't reach the nutrients because they've leached, they've gone into a lower subsoil. If a forest soils start losing their nutrients, trees won't grow. And then they become sensitive to all sorts of things, insects, diseases. If there's drought, there's no rain at all, and the forest will die. Second, acid precipitation increases the level of heavy metals like aluminum. So aluminum also can be released from soil when acid precipitation reacts with the particles in the soil. it gets leached into the soil as well. And aluminum's released from the soil. It moves into soil water, and then it gets washed away to lakes and streams. And so that also happens is the aluminum comes out of the soil. If you look at the diagram at the bottom of page 47, figure 2.16, you'll see that there's a typical forest on the left. That's one that doesn't have acid precipitation, and a forest with acid precipitation on the right. And you'll look at the levels. You'll see on the left, it's got a pH of 5.6. Remember, we said that's the range that a forest can still be healthy. And on the right, you'll see the pH has dropped to 4.0, meaning now that is acidification. Acid rain is falling and causing the pH of the soil to drop to 4.6. You'll look in the left-hand one, the healthy one, healthy forest, and you'll see it's got some aluminum, some hydrogen, calcium, magnesium, all going into the soil, some of it leaching, which is natural. However, if you look at the right-hand side, you'll see the amounts increase. Aluminum, big amounts coming out of the topsoil, and the same with calcium and magnesium, and as well the hydrogen atoms have really increased. So you can see how the nutrients are leached deeper into the subsoil. And the pH levels of the rain and the water moving underground, of the rain and water moving underground, lower considerably. And so that's your groundwater. Or it could also be going off in the surface, right, into lakes or streams. Both ways, it's now going to go off to other parts of that ecosystem and cause all sorts of problems there as well. Aluminum itself can be toxic to plants, fish, birds, etc. It can stop the growth of tree roots, and it can prevent the roots from absorbing calcium. It can reduce organisms living in the soil that keep the soil healthy, and it can stop the decomposing of dead and decaying leaves. Any ecosystem that's got chronic acidification has high levels of aluminum in its soil and water. Remember, we talked about the testing and monitoring of various items, and one of them was soil. And so we talked about that. If you have a high level of aluminum in your soil and in your water, it's a very good sign that you're having problems with the ecosystem that is not healthy. Okay, the third thing acid precipitation can do is it can increase the amount of sulfur and nitrogen in soil. We looked at the sulfur and nitrogen cycles a few nights ago when we were talking about cycles. And you'll recall, and I talked about it right at the beginning of class today, that nitrogen could help actually the forest to grow more in the beginning, but that it's overgrowth. And what eventually happens is that as more and more nitrogen is added, it rises above how much the forest can absorb, and then it starts leaching out of the soil again into surface water and then moving into lakes and streams. And too much nitrogen is as toxic like everything else we've talked about, and can be toxic to the plants and animals living in that area. Question 1 on page 48 of the Check Your Understanding questions. We're on page 48. Question 1 asks, or says, suppose you read that a local lake had undergone acidification. What does this mean? Okay, so what you want to do is just describe what acidification means. What does that mean? We've just talked about it. We've talked about what happens when you have acidification in a forest, but just describe what happens when a lake has undergone acidification. Number 2, describe 3 ways soils can change because of acid precipitation, and we just went through all 3. That questions were 3 marks, and you can look at some of the things get added to the soil, and the diagram on the previous page, on page 47, also shows you very clearly how soil changes because of acid precipitation. In Ontario, um, we have a really hard time with acid precipitation, and that has to do with the geology of our area. Ontario is located mostly on the Canadian Shield, and the Canadian Shield is made up of granite and volcanic rocks. They were formed many, many, many years ago. They are types of rocks that cannot neutralize. Remember, we have acids that are below 7, bases are above 7 on the pH scale. If you want to get rid of acid rain, acidification, you need to neutralize. You need to add something basic. Sometimes, depending on the area, you will have some rocks that are, when they break down, they create a base. And when that happens, that's good because then it can neutralize some of the acid. However, the types of rocks in most of Ontario are very hard, and they don't break down and they don't neutralize the acid rain. You would need a lime base. There are some areas, Kingston has the limestone board, and so that area has limestone. It is the nickname actually of Kingston is the Limestone City, and it has limestone bedrock. That one is a gain agent. All these the Canadian Shield's very old. We have rocks from zero point 0.9 to 3.3 billion years ago, and so the Kingston area is a little bit less. It was 470 million years ago. It used to be a tropical ocean, and the limestone in this area is from that. It's from an area that used to have a tropical ocean, and then of course we had this type of material present from it. That was many, many years ago, and so that area would have limestone, and limestone will neutralize acid. However, in this area where we live, and pretty much over to there, we have very hard granite, and so it does not get neutralized. And sometimes we send quite a bit of acid rain into the environment. If you have a member industry creates pollutions, and those pollutions go into the air. So we have sulfur dioxide, nitrous oxides go into the air. They mix with oxygen, water, and they result in some can be very acidic, 40 times more acidic rainfall at times than natural rain. And it falls back as acid precipitation. There's something like 140, more than 140 Ontario lakes that are dead lakes. They're killed because of acid rain. A lot of them are located in a particular part of Ontario in the Killarney Provincial Park. The rocks in this park are called quartzite. They do not do anything to acid. They cannot neutralize it at all. These lakes are crystal clear, and they have no living plants or animals, and so they're dead. Or some of the other lakes in that area are dying because of acidification. And so that affects us because now we're not able to have any ecosystems there. You can't go in those areas. It's not healthy. You'll see on page 49 and figure 2.18, it's showing you an example of those lakes. They also have nearby Sudbury, and Sudbury is a mining community. It mines nickel. There's a big nickel you can see if you go there. And so a lot of the pollution we talked about, the sulfur dioxides, nitrous oxides, were released from those mines, and that's what happened is they ended up with dead and dying lakes in that area. And the pH has never returned to what it was before all that industry. There's lots of laws nowadays about reducing the amounts of sulfur dioxide and nitrous oxides being released into the air. However, the pollution is still being produced, and over time, chemical conditions of the soil and water will improve. That's what has to improve first, right? You have to have the spheres improve first. The air has to improve so that the chemicals are not being put in the air anymore. And then the soil and surface water, you cannot have continuing to be bombarded by the acid. After they improve, plants then very slowly start to regrow, and animals then can start to move back in. The recovery time really depends on how much damage was done in the first place. So it can take decades for a forest to recover from acid precipitation, but then you have to stop producing the acid precipitation in order to even have a recovery process begin. So it's very important that if an area is receiving acid rain, that it be stopped, but first of all, by producing the pollution that causes it. And then looking at ways to neutralize the acid. I have to be careful about that because even though the acid is neutralized, you can still have issues with the pollution doing other damage as well, and the cleanup effort doing damage. You have to be really careful that the cleanup method doesn't cause more damage as well. Okay, we're going to look at the questions on page 51 now. They're on page 51 of the textbook, and you'll see there that you go back to the key questions over on that booklet. It'll tell you what questions of the review questions to do. The first question is describe one way oil enters an ecosystem accidentally and one way oil enters an ecosystem intentionally. I'm not sure that we can say intentionally. I'm not sure that any time you do anything, it's with intention, but in the reading, it does describe how oil can enter an ecosystem not because you're dumping it, not because, from an accident. So I guess that's another that question is worth 2 marks, 1 mark for a description of each way. Question 4 is the next one. Question 2 and 3 aren't listed in the booklet, so you're going to go to question 4. And question 4 says, what is the difference between an oil slick and a tar ball? So you want to talk about how oil has different, you could have a lighter or a heavier oil, and you want to talk about what happens when each of these is in the water, what the lighter oil does and what the thicker oil does. That is also worth 2 marks. So you want to give it a difference by explaining each of those. Number 6 says, what is the difference between episodic and chronic acidification? And there's a good explanation of that we just went through. Number 7 is not listed in the list of questions, so you're going to go right to number 8. Using figure 2.16, describe how acid precipitation impacts on the release of key nutrients and heavy metals. So remember we were talking there about aluminum, calcium and magnesium, and the hydrogen ions. So they want to know how are those impacted by acid precipitation, and you can look at figure 2.16. It's got a really good description there. Question 9, what is the impact of high amounts of aluminum in soil? So aluminum in particular can do all sorts of things if it has too much in the soil. List a couple. It's worth 2 marks. So you want to list question 8 also was worth 2 marks. So you want to list a couple of ways, a couple of impacts. Number 9 as well, you want to list a couple of impacts. There's lots listed. Question 10. Why is Ontario one of the provinces hardest hit by acid precipitation? So remember, we didn't really talk about it, but if you look at page 49, at the top, figure 2.17, it shows you the different terrestrial ecozones. And you'll see the one there that says the Hudson Plains. That's up on the northern coast of the province. I go to one of those communities quite often, Fort Severn, which is almost kind of over at the very top of Ontario. Then there's the Boreal Shield, and then there's the mixed wood plains. The area that we're talking about, where we're talking about our the Canadian Shield, is mostly where it says the mixed wood plains there. I mean the Boreal Shield. Boreal Shield. It's forests on the Canadian Shield known as the Boreal Shield. And so you can see there that that's the part they're talking about that is really susceptible to acid rain. If you look at that diagram where it says Toronto, London, Hamilton's a huge industrial area. Windsor, right across from Windsor in the United States is Detroit, another huge industrial area. So a lot of times the pollution isn't actually being produced right in our Boreal Shield area, but the pollution is produced down there, and wind will bring up those pollutants to that areas, and that's where the acid rain forms, and then it falls on the Boreal Shield. And we've already talked about why that is so hard on the forest life in that area. Question 10 is worth 1 mark. Question 11 says, many lakes around Killarney Provincial Park are dead or dying because of acid precipitation. What is unique about this area that has contributed to the acidification of these lakes? And if you recall there, we talked about a city, actually, I guess I shouldn't say a town, a city producing chemicals. You can talk about that. And you can talk about what happened to the lakes in that area due to that. And that's worth 1 mark as well. Okay, we're almost at the end of class tonight. So those are your review questions for lesson number 6. We are heading tomorrow into looking at another way that we can affect ecosystems. Humans can affect ecosystems, as well as how that damage can affect us. So tonight we talked about, in particular, oil spills and acid rain, and how we create the oil spill. In the case of the Exxon Valdez, the captain of the Exxon Valdez, I cannot remember his name. Joseph Hazelwood. That's right. He was charged with reckless endangerment, criminal mischief. However, he got off for negligently discharging oil. He never returned to work, I guess, ever. And however, he did get a fine of $50,000, 1,000 hours of community service, and he was his captain's license was suspended. So I guess something came of it. I don't know if that was enough. And tomorrow we're going to look at invasive species, which have been huge in our part of the world lately. There's a couple of species that we have, and they've played havoc with our natural occurring species. And we'll talk about that tomorrow night. Thank you for joining us, and have a great evening.